Hello all, welcome to the fifth video lecture on computer graphics. In this lecture, we are going to cover the topic raster scan display and random scan display. So let's get started. So the topics are as follows. We are going to understand the raster scan display, the random scan display. Then we're going to understand the architecture of each, and we're also going to understand the architecture with the help of a display processor. So let's first check out what is a raster scan system. Now, in this architecture, you can see we have the CPU, we have the system memory, and we have a special purpose processor, which is specifically used for the display. Okay, and we can call it as a display controller, and it is also called as a video controller. Now, here, the frame buffer can be anywhere in the system memory. Okay, so that means the frames that which comes onto the monitor, okay, it needs to be stored in the frame buffer so that the display is faster, the processing is faster. Okay, it looks real time then, but it is going to be a part of some system memory. Okay, and the video controller accesses the frame buffer to refresh the screen. Now, in addition to the video controller, more sophisticated rasters can employ other processors as co-processors and accelerators to implement various graphic operations. Now understand that this display processor or graphic controller or video controller, this particular module, okay, gives direct access to the monitor. That means this monitor is directly going to take the data from this display processor. And this display processor using the system bus communicates with the frame buffer, which is a part of system memory. So still, we can say that there might be some kind of delay in this particular architecture. So we need to improvise on it. We need to work on it. Okay. So let's check what comes up next. So here we can see that the frame buffer is separated out of the system memory. So it's not a part of system memory anymore. And so the video controller now, instead of communicating with the memory through the system bus, it directly communicates with the frame buffer. So you can understand now that this will make the processing kind of real time. Okay, so instead of using the bus, now it is directly accessing the frames from the frame buffer. So now what is stored in this frame buffer, you need to understand. This frame buffer will be holding the frames, the pixels, okay, and the information of the pixels, that what should be the light intensity, what should be the color of the pixel. So all of this information is stored in this frame buffer. Okay, so kind of the scan conversion concept is going to take place over here. Okay, using the algorithms, the video controller is going to take the frames and put it up onto the screen. That is the monitor, which is there on the right hand side. Now let's understand how the things works onto the screen. So on the screen we have the x-axis, we have the y-axis. So you can understand now I'm looking towards the screen from inside that particular device. That means from, suppose we are talking about a TV, so I'm talking from inside the TV, I'm looking at the screen. So obviously for me the lower bottom point, okay, leftmost bottom point would be the origin. But if you're watching the TV, you'll be on the other side, okay, on the just the opposite side of the screen. Okay, so for you the origin will be on the bottom right of the screen. Okay, so for the people who are watching the TV, it's bottom right. For the system, okay, it's bottom left. So how does it work? So the thing is that we set y to y max at the start and x to 0. So this is the x, right? So we set the x to 0, okay, and y2 we set it to y max. Now we start 1 pixel at a time, and this is how the scan conversion goes. Okay, that means we go through all the set of pixels over here in the first row. Then we again the y max is set to 0 in the second scan line. Okay, and in the second scan line again we go from left to right. Again the scan line is set to the next scan line, and again we go from left to right. And this is how we move around. As soon and when we are actually moving around, we see if there's any pixel information stored for that particular pixel, and as soon as we encounter that in the frame buffer, we bring it onto the screen. So you can see when I'm printing every scan line, I'll be printing this particular point of the circle, this particular point of the circle, and that is how this entire circle is going to come into existence. Finally moving from left to right, and I reach the bottom right from inside the monitor. So as soon as I reach over here, I again reset my y-axis to y max and x again to 0. Okay, so this is how I work onto a screen. So let's understand how the refresh operation works for the screen. That means the screen has to refresh, okay, and it has to go for 24 frames per second, 30 frames per second. So you need to understand how this is going to work. So we had just seen that seen that we have the frame buffer, okay, and we had talked about like in the frame buffer we are going to have the information about the particular frame, okay, the pixels, okay, and we are going to bring it through the video controller onto the monitor. So you need to understand that what is the composition of video controller. So you need to understand how video controller refreshes, okay, the refresh operation, how does it take place. So now the frame buffer, okay, it's going to hold up the information about that particular pixel. So how the what is stored in the frame buffer? So you need to understand that the raster scan generator, okay, the scan conversion that takes place, okay, they talk about the X register and the Y register. This is that X axis and the Y axis. Okay, now this X axis and Y axis, okay, it holds some information. So now it takes the information from the memory address, okay, about what is it going to display onto the screen. This particular information for the X and the Y axis is stored inside the frame buffer finally. Okay, and the finally you can see the pixel register takes the data from the frame buffer and the intensity of it is displayed onto the screen. Okay, so this is how it works. So continuously the X register will be changing from left to right, and Y register it will be set to Y max first, and it will come directly till Y equal to 0, and again after the entire screen is done it will be set up to Y max. Okay, so this is how the entire working processing is going to be. Okay, and just understand that when this X and Y axis they are going around, okay, they are taking one pixel at a time, okay, and they are putting up onto the screen. So you need to understand that one pixel is coming at a time. So the beam inside the CRT monitor, it has to be so fast when it is moving from left to right, okay, and covering every single scan line. Okay, it's when it's covering every single scan line. So this entire like processing the entire screen, it should be taking very less time. So you can understand it should be taking almost like a hundredth of a second. Because if I'm talking about 30 frames per second, then it should be at least like a 30th of a second, uh, 1/30th of a second. So that's how fast it has to be. Now, so I hope you have understood the screen. You have understood the so now on the screen you can see raster scan with display processor. So till now we only had a video processor. Now we have a display processor completely. Okay, so it's a different unit altogether. So why do we have this display processor? So you need to understand to make things work faster we have this. So like can we say that it's like a graphic processor that you have in your laptops like NVIDIA AMD graphic processor? Yes, it is the same. Okay, so you can understand your even your graphic card, okay, it has a different separate memory. Okay, so now when you buy it, you say that I need a 2 GB graphic card, I need a 4 GB graphic card. So you can clearly see that this particular display processor also has a display processor memory, and this display processor memory is going to send the data after rasterization into the frame buffer. From frame buffer, it will be taken by the video controller and put up onto the monitor. Okay, so that is how it's going to work, and it's going to be way faster. Okay, now what is the process of this display processor? Okay, work. So the major task of the display processor is digitizing a picture definition given in an application program into a set of pixel intensity values for storage in frame buffer. So this is how it's going to work out. Okay. Now, you also need to understand that this digitization process, okay, and putting it into the frame buffer, okay, is called as scan conversion. So you know we have talked about the basic primitives, and this primitives comes onto the screen. So this is what happens finally. Okay. Now, so the display processor are also designed to perform a number of additional operations. Okay, this functions include generating various line styles like dashes, dotted, or solid. Okay, displaying the color areas, performing certain transformation and manipulations on the displays objects, and like display processor are typically designed to interface with interactive input devices such as a mouse. So this mouse position is moving and it can be seen on the screen. So this display processor is taking care of the position of the mouse pointer as well. Okay. Now, so let's understand the next thing, that is the random scan system. Now, in the random scan system, you can see it's a basic design, and we just have a display processor. Now, what is different in a random scan system. So you need to understand that previously when you saw the previously when you saw the screen, okay, you were going all the way from left to right from top to bottom. So you need to understand that this is not which is going to happen in a random scan system. It's going to work a bit differently. Okay, it's going to take care of only those pixels that needs change in the next frame. So it's not going to go from all the way to the top till the bottom right. Okay, it's going to only focus on those pixels that needs change. So this is a random scan system. So you can understand in a random scan display, electron beam is directed only to the areas of screen where a picture has to be drawn. It is also called vector displays, as it draws picture one line at a time. It can draw and refresh components, lines of a picture in a specified sequence. Pen plotter is an example of random scan display. So if I look at the screen, what is it saying? Okay, it won't be focusing on the first line. That means it even won't be focusing on the second line. It will start focusing onto the screen, okay, or putting up the beam onto the screen from the third line, because from the third line the uh, yeah, circle is coming into effect, okay, and it will go till this line, and the last two lines as well won't be taken care of by the random scan display. Now, so input in the form of an application program is stored in the system memory along with graphic package. Graphics package translates the graphic command in an application program into a display file stored in system memory. This display file is then accessed by the display processor to refresh the screen. The display processor cycles through each command in the display file program. Sometimes the display processor is a random scan, is referred as display processing unit or graphic controller. Now, what are the advantages of it? Okay, higher resolution as compared to raster scan display. Why higher resolution? Because you can understand we are currently only focusing on the position of the object. We are not focusing on the entire screen. So only the beam is going to work that needs change, or only the object which is there under the screen. So obviously the time is more. Okay, the processing is less. Okay, less memory is required because we need not care take care of the entire screen, only of the object. Okay, and obviously the as the complexity is less, the output would be much greater. Okay, so you can say that even the line drawing, okay, can be way smoother. Okay, what is the disadvantages? Now, realistic images with different shades cannot be drawn, so you need to understand that, and there's a kind of a color limitations also. So when we are talking about only an object or a part of the screen, okay, if everything is going to change on the screen, finally the raster scan display would be better than random scan display. So when you're watching a movie or anything which needs a huge transition from one frame to another, and that's how the things are working, and we are talking about ray tracing method, suppose, and all the light effects needs to be taken care of. So in that case, the raster scan display won't be of much use, because if I'm talking about 3 to 4 sources of light and the illumination taken care of from all sources of light onto the screen, so every single frame at a changes, okay, there's a movement, there's a huge effect into the screen, okay. So and it's about the lighting change as well. So that random scan display won't be able to take care of. That's why we move to the basic raster scan display. So this is it. Okay, these are the reference, the Hanan Baker book, okay, from Pearson publication, and these are the some links that I've used. Okay, thank you so much. If you have understood this, kindly like, share, and subscribe. Happy learning. Enjoy computer graphics. Thank you.